our topic is about the Ampere law. Okay, Ampere law states that total magnetic field along closed line will always equal to mu naught times current enclosed. Okay. What is for this total magnetic field along closed line will be always equal to mu naught times current enclosed. Ampere law may be for a discrete system, that may be for a continuous system. So firstly we consider for discrete system. For discrete system, total will be replaced with the total means summation. Okay, total will be represented by the summation I equal to 1 to n. Magnetic field mean B. Okay, that magnetic field will be represented by the B. Okay, that is very important to note that along what stands for the dot. Okay, so that will be stand for dot. Whenever we say that effect along through, then we will use the dot, and closed line will be representing by the delta Li. Okay, so total magnetic field along the closed line. Okay, so that will be defined as okay, that will be always equal representing by equal is this mu naught times. Mu naught mean mu naught. Okay, this will be mu naught. Mu naught times. Times means whenever we say times mean multiplication. When we say that we have taken the two pieces of cake 3 times, then it will mean we will multiply 2 with the 3. If we say that I have taken these things 10 times, then it means we multiply these things with 10. Okay, so times mean multiplication. So this line will be stand for multiplication. Okay, so and current enclosed. So that will be the current enclosed. Okay, so this is actually the Ampere law for discrete system. Okay, but for continuous system, as we know that if there is a continuous system, we know that continuous sum mean integration. So this summation will be replaced with integration. So that the close will be representing by this circle. Close. This circle means close dot delta Li. Okay. No, sorry, not D, DL. And this, because when we localize it, delta L will be replaced with the DL. And indices will be removed because the infinitesimal segment will be behave like a same. They will behave like identical. So there will be no indices. So that delta L will be replaced with the DL. Okay. And that will be equal to mu naught current enclosed. Okay, so this is for Ampere law for a discrete system, and this will be for Ampere law for a continuous system. Now, next is we must know about what is the current density. Okay, before explain before finding the expression for Ampere law for integral form of the Ampere law and differential form of the Ampere law. Firstly, we have to understand what is the current density of it. Okay, Our topic is Ampere law. We were discussing about that is the Ampere law. Okay, we have proved that that is the Ampere law for continuous. Okay. We know about the density. I have already explained what is the density. If that is the charge density, then charge per unit volume will be defined as the charge density. If the charge per surface per area, that will be defined as a charge surface density. If that is the charge per line, then that will be defined as charge linear density. And okay. Similarly, the current density is defined as what is the current density? That is representing by the J, okay, that is the representing, and this representing by the J, and this is equal to current per unit area, because always current pass through any area, any surface. The current per surface, the per area, is defined as a surface current density. Okay. Okay. And according to this, I will be equal to J dot ds. So current density along the surface is defined as a current. Okay, so this is the relation for the current. Sorry. I is equal to this. Okay. In scalar form this, and in the form of current is scalar quantity, current density is vector quantity, and I have already explained the area is also a vector quantity. Okay. So current density, this is the relation for the this is defined as a current density. Okay. Clear? Now question is now putting this value into this equation, okay, Ampere law. Now we are this. So what is the Ampere law? Ampere law now become B dot dl, that is equal to mu naught I. And when we put this value of the I, and so from, if I integrate, I may write I is equal to J this dot ds. So current is equal to this. Okay. So according to this formula, this equal to this. Okay. So magnetic field along the closed line, that will be equal to mu naught J dot ds. Okay. But according to Stokes theorem, closed line integral of any vector along the any vector is always equal to curl of that vector, the surface integral. ये आपने पढ़ा होगा in the vector algebra course. Okay. Closed line integral of any vector will be curl of that surface integral. Okay. Mean you may write in this way that this equal to this. So this is closed line integral, okay, and that will be curl of this. So that will be equal to the ds. Now this equation becomes this. Okay? Oh, sorry. Yes. This will not remain the closed, sorry. This is also a surface integral, this is also a surface integral. We have already explained what is the surface integral, okay? So, this is also for whole surface, this is also for whole surface, okay? So, it means this implies that del cross E equal to mu naught J. So, this was the equation. If we take the divergence both sides, okay, then that will be a del cross B will be mu naught del dot J. Okay, so this will become same. Okay, and this can be write in the form of curly by curly x, curly by curly y, curly by curly z, curly by curly x, dx, dy, dz. Okay. Okay, left hand side, and this is equal to mu naught del cross J. Yes, this because two rows are the same, so this will be a 0. So right hand side become so this will be a 0. Mu naught del cross J. Okay, this will be a 0. Why this right hand side 0? Because the two rows are the same. Okay. Right hand side of equation x is 0, but left hand side will not is not. It may or may not a 0. Okay, but right hand side may or may not 0. Why? Because according to equation of continuity, okay, according to equation of continuity, del dot J plus is equal to 0. Okay, that will be equal to 0. Okay, so according to equation of continuity, this is equal to 0. So right hand side of equation x will be only 0 if partial rho over partial t is equal to 0. Otherwise, this will be not a 0. Okay. But if partial rho over partial t is not equal to 0, then to make equation x consistent, we have to add extra क्या कहा था? Extra quantity, extra factor J prime having same dimension as J, as current density J. Okay, so equation X will become, what will be equation X will become? That will become del dot del cross D equal to mu naught del dot J plus J dash. Okay, or del dot J plus J prime, that is equal to 0 because this side is 0, so that is equal to 0. Yes, since this is 0, so this means del dot J will be equal to minus del dot J. Yes. Yes, but mu naught, because mu naught is not equal to 0. When this term is 0, then mu naught will be multiplied both sides. Okay. So del dot J will be equal, J prime will be equal to minus del J. Okay. हाँ जी, अभी तक ये ठीक है इक्वेशन है, बट फ्रॉम इक्वेशन ऑफ continuity, equation y putting the value of this delta dot J, del dot J is equal to minus rho over T. Yes, del dot J is equal to minus Osama, del dot J equal to minus rho over T. Okay, so this, putting this value into this, sorry, not this, putting this value into this. Okay, del dot J prime equal to minus minus plus okay, this will be equal to this. हेलो, अच्छा तो अच्छा ये जो है ये क्या चीज है, ये आपके डिफरेंशियल फॉर्म आपके था, ठीक है। अब ये जो है ये क्या बन गया था आपके पास म्यू नॉट जे, हमें स्टार्ट से चेंज करना पड़ा था ना, तो दिस वाज बिकम, दिस इक्वेशन वाज बिकम बिकॉज वी हैव एड म्यू नॉट प्लस j prime in here. Okay, if I say this equation is z, okay, because I have added the j prime in the j. Okay, so now we come to this किधर गया? No, so yes, so this will be equal to this. Okay, now put this value, ठीक है, if I say that this is alpha, ठीक है, putting value of j prime from equation alpha, okay, from alpha in equation z, okay, then you will get, now sorry नहीं sorry, हम अभी वैल्यू नहीं पुट कर सकते, अभी हमें इसे सॉल्व करना थोड़ा. This is equal to this because here is a j prime, not a j. But this rho, this density, rho is, I will explain it later, okay, because rho is equal to del dot d, where d is defined as displacement vector, okay, and I have explained it in the other book, okay, where d is displacement vector, okay. So okay, okay, this is equal to this. So from so the alpha will become del dot j prime will become del dot d, okay, over t, okay, and because this is depend upon the position and time, okay, since del depend del is depends upon position so x and t are independent, del and partial t are independent because del is equal to partial over partial, as I have I, plus partial over partial yj plus partial over partial zk. Yes, del is equal to this because they are independent, so they may interchange. Okay. So del and t may interchange with each other. Okay, so they may be interchanged. Okay, when they may interchange, so you may write it that del dot j prime, that will be equal to partial del will become out partial d over partial t. Yes. Okay, and this implies that j prime is equal to partial d over partial t. Okay, put it into equation z. We have क्या आ जाएगा? We have del cross b will be equal to mu naught j plus d over dt. Okay. Okay. This is called this equation is called differential differential form of Ampere law. Okay, this is called this equation is called the differential form of the Ampere law. Okay, and it is also in one of the important equation of Maxwell equation. It is also called the Maxwell equation. Okay, there are four Maxwell equations. That is the one part of the Maxwell equation. Okay, okay. So this is the differential form of Ampere law. Got it? So everything must be very clear.